The quality of air that our kids breathe while at school has never been more important. Whether you want to protect kids from the spread of airborne illnesses like COVID, or protect them from the scary health impacts of toxic air pollution during wildfire smoke events, or simply make sure that the air inside the classroom is fresh enough to allow kids' brains to absorb and process information, good indoor air quality is now mission critical in schools. So, given that one of the key benefits of passive house buildings is superior indoor air quality, thanks to their filtered fresh air ventilation systems, it should come as no surprise that passive house schools are starting to catch on. This passive house schools trend is really taking off in Scotland, but it's also starting to happen here in North America. Let's check out a passive house school project in my hometown of Seattle, Washington, for the Bush School, a private K-12 school here. Designed by Mithun and completed in 2022, the building is Phius pre-certified, Salmon Safe certified, and is targeting net zero energy. The Bush School community sees this building not only as a safe and healthy place for its students, but also as a way to invest in a climate-safe future for those students. Let's join the tour.
Well, maybe to start the conversation, we can talk a little bit about the purpose and need and some of the origins of why this building, why now. We were delighted to start talking with the Bush School in 2016. They were looking at how can we get more functional space on our campus. A lot of these things coalesced into a rethinking of some of the master plan ideas. We worked with the school to think about upper and lower campus, safe crossings, and how to accommodate more space and also navigate the city's lot coverage and other kind of constraining features. That exploration of program was one layer, but then it was quickly apparent with this community that just putting a building down was not good enough, and we needed to really kind of think about what impacts this project could have beyond the property line. We were creating a very visible frontage along Lake Washington Boulevard that was a new visible face. A lot of people have driven by here, didn't even know Bush School existed, and the idea that this is a new front door that's highly visible. So there was a lot of conversation about all the sustainability strategies and it quickly became apparent that energy and water were two really big passion points for the school. And so we came back, we honed in our sort of focus and the idea we crafted a proposal to say, like, what if we thought about passive house? What if we thought about zero energy? And what if we thought about Salmon Safe as kind of a trilogy of ideas that could be brought together in some sort of legible form? And so there was a lot of really wonderful support among the Bush community about that, and it became exciting to think that very few projects in the country have achieved passive house, let alone committed to it, and also none of this scale in our community for educational school buildings in K through 12. So it became kind of a first of opportunity to do something different, but there was also a careful consideration about the cost, the value engineering process, and really protecting some of these visions from the kind of typical erosive process. We kept these ideas sacred. And so relative to the design of the project, there are a lot of layers here to think about, but this building could actually be a bridge to allow for multiple front doors and create an accessibility linkage to the campus was another driving factor. So as we think about passive house, we started looking at a lot of different ideas around what the envelope of the building could be. Was it double stud construction? Was it single stud? And really sort of, you couldn't really grow the building out. We had to grow it in, and when you grow it in, you start sacrificing valuable square feet for classroom spaces and other functions. So there was a lot of interesting and good conversation with PAE, with our PAE, and a lot of our trying to find the sweet spot between constructability and space, and like preserving as much usable, assignable square footage as we could. So anyway, what we have is a pretty rational building, but it's also, we try to penetrate with as much light as we could on every which way, create views out to nature and connections back to the campus. There was a lot of decision making around how to build this relative to our passive house goals and energy goals, but also to reduce our carbon impact. And so a lot of quick analysis of steel and concrete versus wood, and a very strong lean to wood technologies. We looked at CLT, Dow laminated timber, and mass plywood. And given the kind of economics and the supply chain issues at the time, mass plywood really kind of emerged as a clear winner in terms of cost value to the school. And so that became a kind of a resounding, technology that we kind of leaned into and tried to express that wherever we could.
We'll see it more on the inside of the building. What you're looking at here is car decking. This space here is car decking over the timbers. It's because the spans were bigger here. We have about 11, 12 feet between the beams. And also the mass plywood outdoors, there was concerns about long-term weathering of that. So we went with the car decking just in this, what's called the Student Life Center. But since you're interested in Passive House, of course, you're probably looking at this space and saying, this doesn't seem very Passive House-like. But it really starts with the rest of the building, which is a very tight, well-designed envelope, great proportions of glazing to solid wall. We have about, 35% glazing, I think we ended up with. So it was a great coordination between us and PAE to be able to achieve sort of what we're calling sort of the living room here for the students. It's sort of a beacon element for the project. So we're pretty proud of that. And getting it all airtight, with triple glazed Cascadia, fiberglass windows throughout the project, and a great contractor who was very diligent about sealing everything. So we passed our airtightness test with flying colors. So that was very exciting.
Obviously very low.
We also have like an 18 kilowatt PV array on top of this roof, plus another 144, I believe, down on the lower school that was designed for this project to offset our energy. So we are net zero in that respect. There wasn't enough capacity up here or solar access for that much PV, and the lower school had much wider roofs availability and solar access. So all on campus though to offset our energy use. And we're all well aware of the smoke events that we're having, and so having good outdoor air, but filtered outdoor air, and windows that open or you can close was important and discussion points.
The party and organization of the building is pretty rational, I would say. We really had a tight site. We wanted to optimize classroom sizes, minimum functional square footage for educational space between 5 and 550 based on the kind of current Bush models. And so that was kind of a starting point in organizing as wide as we could, kind of corridor spaces for social gathering, small group breakout. You're seeing a lot of transparency at the ends. These are intended to be, gathering and kind of small group learning spaces. But one of the organizing features was also this kind of communal stair and really making this kind of a central piece and making sure we could kind of centralize this and connect all three levels as well as we could.
All the mechanical equipment on the roof is housed over these circulation spaces and not over the classrooms to reduce noise mitigation and vibration into the classrooms, which made it very challenging because the bulk of the roof is over classrooms. And so we have these central spines here of the mechanical ductwork. We hid them with the floating cloud, but left it kind of open on the side, so you still get a little more illusion of some height, because we were challenged with building height due to zoning code, and so it's a little bit shorter of a building than we would otherwise like. But we try to pop up at the ends, as you can see, to kind of open up to the glassy walls at the end.
This is a typical classroom. All the spaces in this building are more general, kind of educational space. There's more specific lab and tech spaces in the Wisner Hall, which is the building across the way. That was a 1997 project. You're starting to see a little bit of the kind of gable framing in this room. This is the half of the building that is more responsive to the kind of more traditional fabric of the campus. There's a lower slope roof system and kind of a different expression of the building adjacent on the other side of the hall that kind of comes together, and partly by intention to break the scale down so that the building actually presents itself as two smaller structures and more of a village kind of motif to the neighborhood rather than one monolithic building along Lake Washington. But where possible, you're seeing daylight in multiple ways, trying to balance kind of natural light, ventilation opportunities, and then a lot of great sort of whiteboard and kind of flexible surfaces inside and outside, and then visual kind of connectivity so that some of these breakout spaces can be used for educators to have small groups and other folks to spill inside and outside. So
Our wall assembly is not particularly exotic. It's a 2x6 wood stud with our 21 batt insulation, exterior plywood, because most of our exterior walls are shear walls, 2 inches of mineral fiber batt insulation, mineral fiber board insulation outboard there, and then the airspace in our brick. So a little bit more robust than code, but not overly exotic. On the roof, obviously all insulation above. It's polyiso insulation, about an R50. So code would be about R39, so a little bit more than code.
Yeah, so we designed it for partial cooling. That was one of the unique things about this building. So it's not fully air conditioned. So that has ceiling fans, so that's part of the air conditioning system. Most mechanical engineering designs would not include that. But part of the concept here was to try to get great envelope and then passive cooling as much as possible too. So all the windows open so we can try to get cooling that way. And there's access to fresh air outdoors. And then great daylighting, and then we do have partial cooling on the dedicated outside air supply system, or DOAS system. So that comes through those units there. So the fresh air is coming in constantly from that location, which helps create a fresh classroom. It used to be classrooms, like in older schools, would not have a ventilation system. So it'd be a chronic thing. I experienced this when I was in school, like getting sleepy in class, which you might think is like the teacher's boring or something, right? But often it can actually be due to CO2 levels. When CO2 levels get higher in a room, above 700 to 1,000 plus, your brain starts to shut down. And I didn't know that till much later in life. So if you've ever experienced that, that's part of why we have these systems now, to try to help avoid that.
Acoustics is also an important aspect of a healthy classroom. You can see there's a variety of acoustic treatment in these spaces that we work on with our acoustic engineer to fine-tune the acoustics.
I think the coolest thing for me, we had an early meeting. So we proposed net zero and passive house and Salmon Safe and a whole lot of other things early on. And it was going to be expensive, and all that kind of dropped off. And some parents came in and said, "What are you doing about the climate crisis?" And why we have to show the kids leadership. And that's the first time I've had a client do that. I feel like I'm always the one saying, let's show leadership. And it was really refreshing to have an owner say, we have to demonstrate that. Culturally, we have to make this broad change where we all are making a priority for that, and that it's something that we put that as kind of truly the house is on fire, how are we going to put it out of fire, and not that it's this add-on after the fact.